Something that all of us do every day is check the time and date. Me personally, I check it at least once an hour. It's something so small in our lives that we use so frequently, and it's really important to us. But what if you are blind? You can't really check the time and date for yourself. Your only option is to ask someone else, but that can get quite annoying if you keep on asking them every 30 minutes or so. And also, you're not always accompanied by a person. So if you don't have anyone near you, you can't really check the time or date by yourself. That's why I built a program that allows you to check the time and date by yourself using your brain. I did this with the help of a brain-computer interface, or a BCI. A BCI is a device that tracks your brain signals and sends them to a computer, which then the signals can be programmed in to output a function. So let's say if I want to press the space bar every time I blink, I can program in my computer saying if you detect a blink, then press the space bar. I use a similar method for this project, but it's a bit more complicated. The specific piece of equipment I use for this project is the ganglion board made by OpenBCI. I can link it in the description below if you want to buy it yourself and try playing around with it. But essentially it's a BCI board with 4 different channels, meaning I can place 4 electrodes around my head. An electrode is the object that actually tracks your brainwaves. So I put it around my head and it's connected to the board, which is then connected to my computer, and it'll send the signals directly. I can program these signals to do a wide variety of tasks. In this case, I told the computer to tell me either the time or date based on my mental state. So essentially, if I'm relaxed, it will tell me the time, and if I'm more alert and concentrated, it'll tell me the date. So if you're blind, all you have to do is relax yourself by closing your eyes and taking a few deep breaths, or open your eyes and be a bit more alert to either know the time or date. So enough of the explaining. I'll show you the code now and break it down for you, explaining each step and exactly how it works. I'll also give you a demo at the end, so stick around. So this right here is the code. It might seem pretty complicated if you're new to Python, but it's really not that hard, and once I break it down for you, it'll seem pretty easy. So at first, we're essentially importing all the libraries that we need. These libraries contain functions that allow us to process the data and achieve our end goal. So BrainFlow is what's commonly used to process BCI data and EEG data, and that's what I'm using for my headset. And then datetime to tell me the date and time, and then NumPy as well for data processing. NumPy is used for lists and arrays, and since the data from my BCI headset comes in the form of an array, NumPy is a very handy library to use. So after that, we're getting to the juicy part. So this is a main function. So essentially everything here is going to be what's used to actually run the program, and in the end I call that function. See right here, main empty brackets means I'm calling the function. So I'm defining all of this and then calling it at once, and I'm repeating it. So essentially I'm putting in the function because it's easier to repeat that way. So first here, what we're doing is defining all of the variables that we need. So params, or parameters actually, that's what they're actually called, and board ID, these help the computer identify the board, and then several other variables I'm defining for to use later in my code. As you can see, this part right here, I'm starting the session. I'm preparing a session and starting the stream, which means starting getting data from my head. So here we're starting the stream, giving it 10 seconds, and essentially we're collecting data from 10 seconds and then stopping the stream, and then the rest of the code uses that data and works with that data to see if I'm relaxed or more alert. So here what I'm doing is a data filter detrend, which is basically a like more filtering for data so that the values are more accurate and easier to work with. So this part might seem scary, but it's all very simple and it's repetitive. So as you can see here, there's 4 major blocks. If count equals 1, if count 2, count equals 3, and count equals 0, count equals 1, count equals 2, and count equals 3. Yeah, not the other one. So these blocks are for filtering. Essentially what it's doing is for each EEG channel, that's what count is. So since there's 4 numbers, it's 4 channels. And for each channel, it's saying it's applying filtering. So for each channel, what it's doing is essentially, so what this part's doing is essentially providing filtering for the data. So as you can see here, there's 4 different major blocks, and that's for each channel. So count equals 0, 1, 2, and 3 are representing each EEG channel. And it's filtering the data from each channel. So here you can see it says band stop. Band stop means it allows all values outside of 58 and 62. And then the other one is band pass. A band pass filter allows all values between 2 values. So in this case it's 11 and 31. So the frequencies are being limited because that's the values, we're limiting to the values that we need only to work with this data, and no other values, because if we have more values it becomes more complicated to work with the data, and it just becomes very noisy, and it's hard to program the data and get accurate results. So then we're getting the band power alpha and beta. So the alpha and beta waves are what's used to measure my relaxation and alertness. Alpha, if it's higher, means I'm more relaxed. If beta is higher, it means I'm concentrated or alert. So these are, I'm collecting the values for these by getting the band power. There's a function to get band power, and I'm saying specific frequencies because alpha waves are between these frequencies and beta waves are between 14 and 30. So I'm getting these values and I'm printing them just so that I know the values, what they are, and if there's anything wrong with the value. Because occasionally the data could be slightly incorrect because obviously I don't have the best equipment. So if it's incorrect, I could see that when it prints the values, and I know that this trial is inaccurate. So then what I'm doing is I'm getting the date and time and storing the variables. So now is getting the date, because you can see datetime.now.date, and then now one is getting the time, datetime.now.time. And then the engine, what it's doing is it's essentially converting it into converting the text into speech. So engine I'm defining as a function and using this library, which is text to speech. I'm essentially saying whatever's in the brackets, you have to say it out loud. And then finally here's the main part of the code. This is what we're doing at the end of what we're trying to accomplish with this code. And we're saying if the band power alpha is less than 10, which means I'm more relaxed, then the engine will say the date, and then it'll run and wait. And then if the beta power is higher than 5, it will say the time. And that essentially reflects when I'm relaxed versus when I'm alert. In the end, I am saying if the ratio of the alpha divided by beta is less than 1, then there's something wrong because that's not supposed to happen. And it'll raise an error saying wrong ratio. And then it'll erase that trial and then redo it. But yeah, the main part of the code is essentially all this. And then at the end, we're just rerunning the function, main function, as I said before. So as you can see, it's not that hard. If you want a more detailed description, actually, you can go check out my article, which I'll put in the description, where I break down the code more detail there, and you can take some more time to actually read through it instead of just a basic explanation that I gave right now. So hopefully you learned something cool with this. I'm definitely going to do more projects in the BCI space for sure. And next time it'll actually be something really cool. I'm thinking of sending a tweet through my brain. So like doing something similar to this, where if I'm more relaxed or more alert, maybe it might be different types of bands next time, but essentially saying if a certain band is higher than a certain value, then send this tweet. So I'm going to try something like that where I have to integrate the Twitter API. I haven't researched anything about it yet, but I'm planning on doing it, so definitely stay tuned for that. But yeah, hopefully you learned something new from this video and you enjoyed it. If you did, consider subscribing and leaving a like. But until next time, peace.
April 18th, 2022. April 18th, 2022. 17:05:05.614304.